So when it comes to converting between empirical measurements and standard measurements, we have to pay attention to the measurement ratio. So in this case, 1 yard is equivalent to 3 feet. So in order to convert yards to feet, we take the given amount in the question, which in this case is 28 yards, and then we're going to multiply it by the ratio between the given and the required. Now the required is in feet, so the number of feet, it's 3 feet per 1 yard. That is the given ratio. What we want, remember, always goes on the top. So I'm going to write here required on the top. And then once you've placed your equation like such, then the like terms, for example, the 28 yards and the 1 yard, those cancel out and you're left with just feet. And this gives us a final answer of 84 feet. So remember, whatever you're given, multiply that by the ratio between the desired or required unit and the given unit. In this case, there is 3 feet per yard, so we took 28 yards, multiplied by 3 feet per 1 yard, canceled out the yards, and then we got 84 feet. So another question in the measurement unit that is a typical exam-like question would be this following of a 3D shape. So the volume of this box is 392 centimeters cubed, so I'm just going to highlight that because usually when that is given, you're going to probably use it later. So the question is, if the value of x is 7 centimeters, so we're talking about this, so it's got a square base here, so this and this is 7 centimeters. What is the value of h, namely the purple over here, and the surface area of the box? The other important information that was left out, I think by accident, was to mention that it's a square base. So the x and the x tells us that it is a square base. So the box has a square base, and that's going to help us determine the proper formulas. Okay, so the first thing we're going to do is write down all relevant formulas for the given prison. So the volume is length times width times height. The surface area for a square base, and that's why I needed to clarify that, is 2a squared plus 4ah. And again, all these formulas would be given to you in the final exam. So whatever formula is made available to you on the formula sheet, those are the only shapes that you're going to deal with. So a here refers to the, you could say the base edge. So that would be the x's. So the base edge. And that's what the a refers to here. So what we're going to do is we're going to rewrite that surface area formula and just put x's instead of a since we're given x. So 2x squared plus 4xh. So the next thing we're going to do is we're going to solve for any unknown variables because you can see that we are going to need height for both, and we don't have height. Now, between the two formulas, and it doesn't matter which formula you use as long as you have all the variables needed, we're going to try and solve for height. So we're given a volume over here, 392 centimeters cubed. So, and we have the x value, which in this case, if I translate my volume formula, the L and the W is going to be the x because there are no other dimensions here. So x times h, and then really that's just going to be x squared h. So we could use the volume formula, v is equal to x squared h, and isolate for h since we're given the volume and the x value of 7 centimeters. So the volume here, in brackets, we go 392 centimeters cubed equals 7 centimeters squared multiplied by h. We're going to isolate for h by dividing both sides by 7 centimeters squared, just like so. And when you plug that into your calculator, you're going to get an h value of about 8. Now I have my h value. I already had my x value. I could just plug it directly into the surface area equation. So 2 times 7 squared plus 4 times 7 times 8. And then I get a surface area of 322 centimeters squared. So I used the volume formula to isolate for an unknown, and then we just plugged it in. And I guess this part over here is really step 3. We could just call that the plug-in. Okay, so once you solve for an unknown variable, the third step would be to plug it. Okay, so we have a right angle triangle here, and it says using the proper trig ratio, so that's your sine, cosine, and your tangent, solve for x. So the first thing that we're going to do is, and I'm going to write it down here, we're going to write label sides of the triangle. That way, you know which one is the hypotenuse, which one is the opposite and adjacent angle. So the largest side is always the hypotenuse, so the 5 here corresponds to the hypotenuse. Now, if this angle x is positioned here, the side that is right across from the angle, that's your opposite side, right? Because it's on the opposite side of the angle, we call it the opposite side. So over here, this is going to be the opposite. And then once you've identified your hypotenuse and your opposite, then the side left, which would be this one over here, this is going to be your adjacent side. So I find it's always easiest to identify the hypotenuse and the opposite first, and then whichever side remains, then you label that as the adjacent. The next thing is, based on what's given, I'm going to underline the word given, meaning the sides that are given. In this case, that's the 3 and the 5. Choose the appropriate trig function. So we have the acronym SOHCAHTOA. And that's just really an abbreviation to associate the proper sides with the formulas. So if we're going to use the sine formula, then we need to be given the opposite and the hypotenuse. If we're going to be using the cosine formula, then we need to be given the adjacent and the hypotenuse. And then, of course, if we're going to use the tan, we need to be given the opposite and the adjacent. Now in this case, what are we given? When we look back at our triangle, and we can see that we're given the opposite, so the hypotenuse and the opposite over here. So that would make sine the appropriate formula to use. So we're going to write sine, and we're going to write sine theta, and theta just refers to the angle that we're going to find, in this case x. Sine theta is equal to opposite over hypotenuse, which in this case, the opposite is the 3, and the hypotenuse is the 5. Now, remember, when you're trying to find the actual angle, you don't just plug in sine 3 over 5. You're going to write sine inverse, and it's a function, I believe the second function in your calculator, and then write 3 over 5. So when you do sine inverse 3 over 5, you end up getting an angle in degrees of 37 degrees, and so we say that x is equal to 37 degrees. Okay, so let's say we want to simplify and convert into a radical. We have an exponential over here, and we're going to simplify it first into a single exponent, and then convert that to a radical. So remember that when we're dividing, right, and I'll point to the line here, that means that we must subtract the exponents, because when you divide numbers with the same base, or I should say exponents with the same base, but different exponents, you have to subtract. So we're going to go x. Now you can only subtract like terms, right? So the x over here is going to be subtracted by the x. This has an invisible 1 over the top. So x to the 7 divided by x to the 1 is the same thing as going x7 minus 1. So that part here is going to convert into x to the 6. And then we have y to the negative 5 minus y to the negative 3. Well, that's the same thing as saying minus 5 minus minus 3. And that's going to be y to the negative 2. So here now we have a simplified exponential expression here. So we won't ask you to convert the radical above. That is too complicated for grade 10. But we could ask you to convert from an exponent like this, x to the 1 over 6, to radical 4. In this case, you have to remember the property that x to the m over n, which is a rational exponent, is equal to the root of x to the m to the n index. So, if I'm trying to relate this back to this formula here, your 1 is going to be the m, and your 6 is going to be the n. And so, when I convert x to the 1 6, and I make that equal, I'm going to go root x, and for the m value inside the root, I'm going to put a 1, and for the n value, I'm going to put a 6. And so here is a perfect example of how to convert a radical, how to convert an exponent to a radical. Lastly, imagine we're being asked to simplify the following radical. And to do that, we're essentially asked to divide, right? That line over here means divide this radical expression. So whenever we have a radical as a denominator, the first thing we're going to do is we're going to simplify, or I should say rationalize the denominator. Now what that means is that I'm going to multiply both the denominator and the numerator by the conjugate of the denominator. Now the conjugate means the opposite. So you see here where it reads 4 minus root 5, it's going to be 4 plus root 5, and I'm going to multiply both the numerator and the denominator with that conjugate. The next thing I'm going to do is I'm going to FOIL. So I'll place brackets around anything that doesn't have a bracket yet, and we're going to multiply as you can see here. And everything gets multiplied by everything. And it looks kind of messy, so I suggest that you sort of organize your work accordingly and make sure not to drop any negatives. Again, making sure you've done this part carefully, you should get the following for the numerator over here. And then you should get the following for the denominator right down here. Lastly, we're going to simplify. Now, rational expressions or radicals are kind of like terms where you could only add or subtract radicals that have the same radicand or number under the root. In this case, none of these in the numerator have the same radicand, so they can't be added or subtracted, so we would leave them as is. However, over here, I could see that these two have the same radicand of root 5, and these two, I'm going to highlight them in purple, have no radicand, so those are like terms. So, when we simplify, our expression should look like this. And so we should have 4 root 5 plus 8 root 2 plus 2 root 10 all over 11. And that's as much as you can simplify here. Okay, so for the polynomials unit, let's say we're asked to write a simplified expression for the shaded region in expanded form. So that would be the shaded region over here. So for the shaded area, remember that it's the larger shape, in this case, the rectangle here. So this is the larger rectangle, minus the dimensions of the smaller shape. And this would give us the shaded area of whatever it is that we're trying to find. So remember that area, especially for a rectangle, is length times width. So when I expand this, it's going to be length times width, and this is going to be for the larger shape. And then I'm going to highlight that in kind of turquoise, and then the smaller shape is going to be in purple. And so here, length times width, subtracted by length times width, but that's going to be for the smaller shape over here. So when I expand this here, the length for the larger shape is going to be 3x plus 5 multiplied by 2x minus 4. And then that is going to be, and I'm going to highlight this again, or keep this highlighted so we understand what's being expanded into what. And then that's going to be minus 5 times x minus 1. And that's going to be highlighted into purple. What we're going to do now is we're going to FOIL this out and simplify it. So once I FOIL and simplify, I should have this expression 6x squared minus 12x plus 10x minus 20 minus 5x plus 5. And like radicals, you can only add and subtract like terms. So there is no other 6x squared, so I'm going to leave that as is. But the minus 12x plus 10x minus 5x, those can be added together. And when we do add them all together, we get minus 7x. And then, of course, the non-x's, the negative 20 and the 5, can also be added or subtracted together. And when we do that, we get negative 15. So here is the simplified expression for the area of the shaded region of that rectangle. So what is the greatest common factor in this expression 28x cubed minus 24x squared? What's the result when we remove this factor? So the thing is, when we are asking for the greatest common factor, you're thinking about what's the greatest number or variable you can divide both or everything in the expression by without getting into a decimal. So I'm going to look at the digits first, or I should say the coefficients first over here. And so if I'm thinking about between 28 and 24, or negative 24, I think the biggest number I can divide each by without going into a decimal is 4. So I'm going to take 4 and then set it to the side. Now, we can go to the variables and we see that they both have x. Now, what's the highest degree of x they both share? In this case, that would be x squared, because I have an x squared here and I have an x cubed there, which within the x cubed, there's an x squared. So that answers part A. But then part B asks, if I were to actually remove this factor, and when we say remove, you're really just dividing each term by it. What would the result be? So imagine we took 28x cubed and we divided by 4x squared. You'd be left with 7x. And then if we took minus 24x squared and we divided by 4x squared, we'd have minus 6. So this would be the expression or the result if we actually removed that factor. So let's say we're asked to factor this trinomial fully. What we're going to do is we're going to multiply. Remember that this is the A, this is the B, and this is the C. So we'll multiply the A and the C together. And that is going to give us 40x squared. Because remember that there's always an invisible one right by where the x is. The second thing I'm going to do is I'm going to list all factors of A times C and choose ones that actually add up to B, or the value of 13x. So I have 1x, 40x, 2x, 20x. I'll just dot them here as we go. I have then 4x and 10x, and then 5x and 8x. And of course, 5x and 8x are the ones that actually add up to 13x. So we're going to select these two. And then using those two factors that we chose in step 2, we're going to factor x by grouping. So I'm going to go x squared plus 5x plus 8x. All we're doing is, instead of writing 13x, we're just breaking it down into 5x and 8x. But it's really the same thing. Plus 8x plus 40. Okay, then I'm going to separate these into two. I'm going to factor it out. So when I look at x squared plus 5x, the common factor that they both share would be x. So if I remove x from both, I get x plus 5. And then between 8x and 40, the greatest common factor that we have for each of them is going to be 8. And so if I remove 8 from each, I'm going to have 8x plus 5. Now, if I factor this expression over here even further, I can see that they both have x plus 5, so I'm going to factor out x plus 5. And when I remove x plus 5 from each, I'm left with x plus 8. And so that gets listed as the other factor. And so my factors here are x plus 5 and x plus 8. So let's say we're given a set of points, A and B, and we want to know what the slope of the line is. So the slope of a line formed by points A at 6 and -1 and B 4 and -4 is. So we're going to label this as x1, y1, x2, y2. And because graphs are read from left to right, we're going to assume that that is the order that they've given us in. So the slope formula is y2 minus y1, or change in y over change in x. And that can also be translated to y2 minus y1 over x2 minus x1. And I have to make sure to keep the values here, so I'm going to go -4 minus -1 divided by 4 minus 6. And so two negatives make a positive, so that would give us -3, and then 4 minus 6 is -2, which a negative divided by a negative is going to simplify to 3/2, and that would be the slope. Now let's say as a follow-up question, we're asked to develop an equation of a line that is parallel to the line above, right? So to this, to the line that would have these points above, and that passes through -1 and 2. So if it's parallel, remember, that means that it's going to have the same slope as this. So what I could do is first, I'll write a slope-intercept equation with everything they already know. So y equals 3/2x plus b. Now, I'm given my x-coordinate, which is -1, and I'm given my y-coordinate, which is 2. So I could plug in the 2 for y, and then the -1 into x, and then all I'd have to do from here is then isolate for b, and then I can have the b part of the equation and get the whole equation. So once I've isolated for my b value, which I got is 7 over here, I can just plug it all in, which is y is equal to 3/2x plus 7. And then here is the equation that is parallel to the one that we had worked out a little bit above.